And let me share. Okay, welcome everyone. This is the very last webinar of the class. And I expect it to be short actually, because there's just one chapter to talk about. I tend to do a little less at the very end for a couple reasons. One is project 2 is due, and that should be your main focus. And the other, especially those who are Lake Tahoe Community College regular students, you're busy with your finals and your other classes. So I try to lighten up at the end a little bit. So today, you can see we don't have a long list of things to do. As always, I'll answer questions if you have any questions. And then, this may mean nothing to you, ANOVA. And it is the last statistical test that we do in this class. Does that mean there are no more statistical tests? Yeah, definitely that's not what it means. There are many, 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 many statistical tests. In fact, I actually just made one up a week ago. And when I say made one up, it doesn't mean done some bad thing, but I designed a statistical test to work with what we were working with at our college for looking to see if pre-calculus helps calculus. And I created a statistical test. And it was, because I'm a professor of it, so I'm able to do that, and it was mathematically sound, and we were able to get a small p-value and show that, yeah, it was helpful. So, but we couldn't use any of the basic stuff. It wouldn't work. So I want to give you a heads up. This is the last day of this class in statistics. It doesn't mean that there's no more statistics ever to learn. So if you end up with a master's degree, you're going to see that. You're going to end up having to do a lot more. So I want to give you, don't get mad at me for like not covering everything there is in statistics, because this is an elementary stats class and not some kind of graduate level thing or anything like that. So, but I do want to give you that heads up. So we will be doing ANOVA. ANOVA is an important test. We tend to do the most important tests. It's used a lot in psychology. And by the way, I think I've taken one psychology class in my life, so don't ask me to explain why, because I have no idea. But the psychology professors tell me that that's the big one for them. Okay, I know what it does, but I'm not I'm not an expert in psychology, so don't expect me to be. But it is used in psychology, and the idea, it's one of the things we haven't done yet that you might think about. So we've talked about a hypothesis test for a proportion, for two proportions, right? For qualitative data, even when there's many proportions, we've talked about a mean, comparing two means, right? What if we want to compare three means? That we haven't talked about, or four means, or five means, right? If we want to find out, I don't know, is the average weight the same in every state in America of people, right? A lot of you think probably not. If you've ever been to Alabama, you know what I'm talking about. But again, I only know from, kind of firsthand looking at a few people. I don't know statistically. But if you want to find out, all of a sudden you're comparing 50 different means. And we don't know how to do that yet. But we will be able to today, because that's what we're doing. That's what this ANOVA is going to be doing, is it's going to see among many means, are they all the same, or are they not all the same? So that's the plan, and that tends to be important. It happens in lots of places, not just, how much people weigh in different states, but all over the place, where you might have three different things that you're trying out and see which is better. Are they all the same? Okay. I will also let you know that you're gonna feel comfortable and think you understand ANOVA by the end of today. And if you do think that, you're wrong. So I want to give you a big warning. We're only doing the very beginning of ANOVA, and there's a lot more to it. So I'll talk about the requirements for ANOVA. We've already seen the requirements for other statistical tests, right? So for example, if your sample size is not very big and you're doing maybe two means, you got to have a normal distribution for both. You also have to have, you can't have bias pretty much in anything you do in statistics. If you have bias, then you have a bunch of worthless, data. Does that make sense? Okay. And by the way, I should let you know your project is worthless in terms of like scientific research, project 2, because you're going to have bias. And most of you are probably going to inconvenience sampling. Just fine for project 2. It's not fine if you wanted to use it, say, for a thesis or something, or putting something in public for everyone to learn about. It's fine for project 2 because we're just can only focus on so much. But in the real world, that's not okay. So we're going to have some requirements for ANOVA and many more requirements than we've seen before. And what we're not going to do is I'm not going to explain at all how to decide if all the requirements are met. That's what I mentioned. You need to take another stats class for that because that's more advanced statistics to see if that's true or not. But it can be done. And then I just put this here, project 2 chat, because project 2 is due on Sunday. And if you haven't already sent your draft, you have to send it between now and 8 a.m. on Thursday. Otherwise, I don't look at your draft. That's my rule. Same rule as project 1. And I mentioned it before, this isn't new. So this is a good time to chat about the project, and I'll give you some ideas on where people make mistakes and where things go wrong and go right and that kind of stuff. And I'll mention a little bit of that because we don't have that much to talk about today. As you can see, I want to mention a couple things just before I get into ANOVA. One is this course is over next week. Hopefully you all know that. And if you look at the syllabus in here, I think I put it in the syllabus. If not, I told you. The exam, I know what it is. It's the very bottom. The exam, which I call the final exam, but that's because it's the last exam, but it's not worth any more points than the other exam. It's due on Wednesday night. So you have to have done it by Wednesday night. And if you don't do it by Wednesday night, you get a 0. So that's not okay. You can't ask for extra time on this one because of course the class is over. If you wanted to do it the following week, nope. I'm going to be visiting family. And maybe you'll do the same thing. I don't know. But the point is that this is, one thing about final exams is you have to do them on the day they happen. So that'll be Wednesday by Wednesday night. And if you do it Wednesday night, it might take me a little longer to grade. And the reason is I'm actually on a hiring committee. Thursday and Friday, I'm going to be in meetings all day Thursday and all day Friday. So don't be surprised if it takes me a little longer than usual to grade, just because in a way, it's the most important thing we do at this college is make sure we have good teachers. So we got to hire a really good faculty member for the committee that I'm on. So just let you know that's happening, which means I don't have office hours on Thursday and Friday. Even if the class wasn't over, I wouldn't because of this hiring committee, but the class will be over. The other thing is it really is over. Okay, don't ask me, what can I do now to change my grade? There is no way to change a grade after that. Okay, after Friday night, the class is over. Okay, and just a few more notes. There's no extra credit in this class. Don't ask because I'll say no. You probably got an email, and it wasn't spam, by the way, to fill out a survey. And what I've heard from other people who filled it out, it takes about 10 minutes. And you get $25 to fill it out. So if you do the math, that's $150 an hour. So if you make more than that, then it's not worth it. You could do it for be nice, but my guess is most of you don't make more than 150 an hour. I don't. So you might as well do it. It's not like painful or anything. So there's a survey to fill out, and you should have gotten an email about that. But there is no extra credit because I figured you get enough money. I don't really give extra credit in this class. So just let you know that. So don't even ask for extra credit. And just note the final exam is worth the same as the rest of exams, 10%. The project 2, let's go to our syllabus. So the project 2 is also worth 10%. So there's 20% left in this class, basically, plus a tiny bit for the assignments due. Might be 21% left. Okay, so in terms of your grade, most of your grade is over. You have it. If you have an A in the class, you should be smiling. I mean, you could still go down if you like really do badly on these things, but the point is what you're getting now is pretty similar to what you're going to end up getting in the class. You know, it doesn't mean you should slack off if you're doing well, though. You know, still work hard for the last, you know, next 8 days. And that's just a note in terms of what's coming up and what the class is in terms of exams and percents and stuff. So hopefully that gave you some idea of what's going on. Any questions about anything? I'm checking the chat box, also listening. I'll be happy to answer any questions. And I also, and hopefully you realize I do check the Q&A board often, and I check the Project 2 discussion board often. So if you post anything in those, and that's where you want to post most questions, unless they're personal, so that everyone can benefit from the communication that happens. Okay, so, you know, always feel free to do that, and I'll be checking, you know, unless I don't have electricity and internet. And unfortunately, this is a winter that's never going to end. If you're in Tahoe, you know what I'm talking about, because I'm looking out my window and it's snowing again, and we could lose electricity and internet, and I can't do anything about that. But hopefully we won't. They're talking about snow, but they're not talking about heavy wind, and that's usually a good sign for electricity and internet. But you never know. But today's the second day of spring, and it's not feeling at all like it, because we're getting heavy snow right now. So just to note. Any questions? Any questions? Okay, if there's no questions, let me go on and talk about ANOVA. I want to mention one thing that is something that doesn't work very well, and please don't get angry at me for what the statisticians have done, and that is what ANOVA stands for. And I'm going to say it kind of quickly because I don't want to like confuse the hell out of y'all. It actually stands for Analysis of Variance. That's what ANOVA stands for. But for us, it'll have nothing to do with variance. So it's really about means. It should really be called, I don't know, CompMe for comparing means, because that'd be a much better word for what we're doing than ANOVA. If you go into the heavy mathematics, you do variance stuff, but we don't do that in this class. But I just want to let you know, don't think that because this is called analysis of variance, that this is a hypothesis test about variance, because it's not. Okay, so that's just a big note. So it's called ANOVA, but I think it's really poorly named. And for those who, if anyone's watching this on YouTube and like says, well, no, it had a great name because that's the mathematics, and I really don't think so. So that's just a note. And here is, and by the way, I wrote it out, capital AN, capital O, and capital VA to show you the ANOVA, where it's coming from. And here is what it is in general. It's a hypothesis test to see if several means are equal or not. Okay. And H naught, this is going to be very different than anything we've seen before. And I do it this way because it's really the only way I've found that students could figure it out and understand it all. I used to do it when I first taught. I did it a different way, and nobody was able to get H1 because the symbols were just too confusing. So I did it this way. Now most people can understand. And H naught is mu1 equals mu2 equals, and I go dot, dot, dot. That means keep going until you're done, equals mu n. So if we were talking about something like, you know, average weight of people in the different states, and are they all the same? That'd be like mu sub California equals mu sub Nevada equals mu sub Arizona equals mu sub Vermont equals mu sub North Dakota. I mean, on and on and on. I don't want to say them all because that would take forever with 50 of them. That's one reason why you use dot, dot, dot. If you only have like 3 or 4, you usually don't use dot, dot, dot. So if you wanted to find out if, I don't know, if IQ was the same for people born in the 4 seasons, then you'd say mu1 equals mu2 equals mu3 equals mu4, because it's just 4 seasons. Or if you want mu summer equals mu fall equals mu winter equals mu spring. Okay, you should all know what the symbol mu means. That's population mean. Okay, any questions on H naught? Okay, now comes the part that a lot of people make mistakes on. So I want to mention this. Okay, you might say, what would H1 be? So you'd say, well, if H naught is that they're all the same, then you might think, well, H1 is they're all different. What's wrong with that? Any thoughts? What's wrong with saying that H1 is that they're all different? All the means are different from each other. Any thoughts? It's a common.
Wouldn't they already be different?
They're already different?
Yeah, wouldn't they already be different, the means to each state?
No, so I thought they're all different. So here's the reason. Okay, H naught is that they're all the same. And what you're always trying to say is that H naught is false, right? So let's say California's average weight was the same as Oregon's average weight. But let's say Alabama's average weight was higher than that. Then there's 2 that are the same and 1 that's different. They're not all different. Do you see that? But they're not all the same. So H naught would be false if California and Oregon were the same, but maybe the rest of the states were different. Do you see? But they wouldn't all be different because some are the same. Okay, so that's something that a lot of people have trouble with, is reconciling the fact that all different is not the saying H naught is false. Okay, so this is why I write it this way. At least 2 of the population means differ from each other. Okay, and if we were talking, for example, the weight in states, you'd say there are at least 2 states whose population mean weights are not the same as each other. Okay, so again, you want to put it in the context of the question. So if it's about weight, you should have the word weight in there. If it's about states, you should have the word states in there, you know, or whatever you have to be studying. Any questions on that? Okay, and there's a lot of ANOVA. ANOVA happens a lot. Sometimes, like, you can compare people in states, and other things that people compare a lot would be race. Say, is there a difference between the population mean income by racial group? Or are they all the same? Okay, studies have been done. Any guess? Do you think they're different? Or do you think they're all the same? In America?
Different?
Yeah, they're different. They're different. And again, the studies have been done. And again, hopefully you understand, you can only do it with statistics. There's no way in the world you're going to be able to get an information on every single person's income in America, right? IRS can do that, but that's secret information that they don't give out to anyone, for good reasons, by the way. So all you can do is do a survey. So you have to use statistics. You cannot do a census. You cannot get the whole population, but you can do statistics to find out if there's a difference in income. Okay. There are many, many, many different times that you're going to be comparing more than one. Okay, does that make sense? Happens all the time. It gets a little messy because, like, if I were doing an example with states, you'd have to type in 50 different sample means. And I wouldn't do that to you because I think that I'm not that evil. It may feel like it sometimes, but I'm really not. Okay, so I'll keep it kind of low, but in the real world, sometimes you do have to have 50 different ones, and you have a lot of typing to do. Okay, or computer input or whatever you're doing. Okay, any questions about H0 and H1? Okay, so here comes the requirements, and there's a lot of them. Okay, and by the way, I don't expect you to completely understand how to decide if the requirements are met, but I do want you to know the requirements. Okay, and again, you have to memorize, but you better know how to find them and understand what they are, not to know how whether they're met or not, but what they are. Okay, the first is all sampling distributions must be approximately normal. Okay, now we found from the central limit theorem, if the sample size is over 30, then you get a normal approximation. So there's no problem. So I just want to let you know, if you needed a sample size over 30, and you were doing the example with weights and states in the United States, that would mean that you would have to have 31 at least from every state in the United States. Okay, it doesn't sound like much until you start doing the multiplication, right? That's 1,550 people you would have to survey from all over the US. So you can't just go, go to your town. That won't work. Do you see? So this could be monstrous. Okay. If you happen to know you start with a distribution that's normal, then you don't have to get that over 30. But if you don't, you need to get over 30 for each. And that's a lot of work. Any questions on that? Okay, so the next one is that all of the population standard deviations must be equal. Okay, and by the way, if they're close to equal, that's good enough to be able to do ANOVA. Okay, you'll have a little bit of error, but not that much. But if the standard deviations are all over the place, don't do ANOVA. Okay, do we know how to decide if the standard deviations are all close to each other? The answer is no. Does that mean it can't be done? No. What do you have to do if you want to find out how to do it? You guys know? Today's the day I'm going to be saying this a lot. You need to take an upper division statistics class. Because we're done with this class after today. We don't have time to do this kind of stuff. But in an upper division statistics class, you can actually do this with a different hypothesis test and all kinds of work. So there are tests for this, but we can't do it in our class. All I can do is say there is one and stop there. Okay. So the other is you have to not have any bias. And we talked about that in chapter 1. There's nothing special about many samples, just you better not have bias. Okay. So typically simple random sampling is no bias, but there are ways of doing it so that you can kind of be kind of like simple random sampling. Some really good stratified sampling, for example, could work. Okay. The other is the samples must be independent of each other. That's actually not hard, but you have to just pay attention. So that's, so the idea is you couldn't say, ask people, let's say, you can't say take their heart rate every hour for the next 24 hours and find out if there's a difference in heart rate by hour, and then maybe look at 30 people or maybe 35 people, because that would be dependent. Because each person, it would be the same person with 24 different heart rates for each hour. Do you see how that works? So that would be an example where you'd have dependent sampling instead of independent sampling. Okay, most of the time it's independent and there's no worry. But you should pay attention just in case. So you want to make sure you're not comparing several answers to a survey question, because that would be dependent. Any questions on that idea? So that one's an easy one to check. And then the other one is the samples are consistently taken. Okay, this one sounds easier than it is actually. So let me give you an example. Let's suppose that you're going to be, let's do the weight example in states. I like that one because it's easy to understand. So if you want to do that, and that means you got to have a large sample size, and you're gonna weigh people. You're not going to trust them. Because if you ask someone how much they weigh, I'd say a high percent are going to lie. Sound right? Okay, if you ask me, I'm going to say, I don't know, I haven't weighed myself in ages. I don't know how much I weigh. But a lot of people will just lie because they don't want to tell you how much they weigh. So really, to do it right, you have to weigh them. Okay, well, if you had to do it yourself, what would you have to do if you wanted to do that to find out if weight's the same in every state?
You'd have to like gather all the people and literally weigh them, put them on a scale.
Yeah, you could gather them. That would be a nightmare. Expensive. Yeah. You'd have to fly them all to your town.
Yeah.
Do you know how expensive that would be? We're talking about over 1,500 people.
Too expensive.
Yeah, that's not going to happen. Okay, no one would spend that money. No matter how much you pleaded your client, they're not going to do it. So here's what you really do. What you do is you hire people from every state, and you say, you go ahead and do a random sample surveying 31 people in your state, and I'll give you a few $100. Do you see? Which is a lot less than flying everyone over, by the way. And then they do that. So then what you have to do is, for them to be consistently taken, you have to make sure that each of the people that you've hired is doing it in the same way. So for example, if one person is doing it right, a little bit after the Christmas holiday, people tend to weigh more. Whereas someone else might be doing it, a little before Thanksgiving when people weigh less. That would be wrong. Do you see? If, say, New York, you did it after Christmas holiday, and then they did it a little before Thanksgiving in Pennsylvania, that's not okay, because that wouldn't be consistently taken. Do you see how that works? And I think I mentioned one of my first jobs ever when I was 11 years old. Did I tell you guys that? It's one that my boss today would be arrested and put in jail for, because you can't make 11-year-olds work anymore. I actually worked doing surveys. I worked for Carroll Davis Market Research Company. Okay, nothing to do with being a stats professor. I was 11 years old. Okay, had to do with my grandmother was working there, and so I was able to make a little money. So what we would do is, and I was just one of the people that called people on the phone, you know what I mean? Is we would have a meeting before the survey starts of all the people doing the phone calling. And in that meeting, we would be told exactly what to do and how to do it and when to do it, so that we were all consistently delivering the survey. And that works. So that's how you make it happen. Is you have a meeting. Okay, and you pay attention, in case it's not people doing surveys or whatever, but you have to make sure that you're doing the kind of the same way of sampling, same timing, things like that. Any questions on the requirements? Okay, so these are the requirements again. Number 2 is the one that you'll have no idea how to do, which is okay, because that's not what this class is about. But you just have to know that it's there, which means that if you think you can do ANOVA right, by the end of the day, or even by the end of this class, you're wrong, because you have to be able to do all these different things, which is a lot of work, but especially number 2. So that's just a note. If any of these are wrong, then you can't do ANOVA. And by the way, if you have bias, you can't do anything. Yeah, bias is like the worst thing that could happen in statistics. And hopefully you've got that. Hopefully I've hammered that down enough times. You just shouldn't be, publishing research if you have bad bias. Any questions at all on the requirements? Okay, if not, let's do an example. Okay, and I made this up, by the way. Just a note. So I made this up. Suppose that a study was done. And in fact, whenever I say the word suppose, that means I made it up. Okay, suppose that a study was done to analyze the racial differences for the distance in miles that people live from the nearest library. Okay, so for example, I live 2 miles from the nearest, and I'm going to call it public library. Okay, from the nearest public library. Okay, if you call a college a public library, which I call it a college library, then I live less than a mile. But for public libraries, we have one in Tahoe, and I live 2 miles from there. Okay. The data from the study are shown below. And what we looked at are white, black, Hispanic, and other. Okay. In the real world, you'd probably have more races than that. But again, I didn't want to spend all day long typing because we're going to have to do this. Okay. And you'll see that the first person who was white answered 15. They live 15 miles from the nearest public library. Second said 4, right? The first black person said 15. The second said, I live 1 mile from the library. Okay, and you can kind of read this table. Any questions on that? Okay, so what assumptions must you make in order to perform an ANOVA test? So now what we're going to do, let me go up and look at the requirements. I'm just going to copy and paste them and take a look to see if we need to assume them or if we know them. Does that make sense? Hopefully you know the difference between, I hate when that's at 6. It was supposed to be A. Let's call it 1. Okay, all sampling distributions are approximately normal. Do we need to assume that? How come?
The sample size is not over 30.
Right, and I'm gonna fix your grammar. The
Okay.
sample sizes are not over 30
Okay.
because we have 4 different sample sizes. Do you see that? So if there were, let's say of those 4, let's say there were 10 of each, that wouldn't be over 30, even though you've asked 40 people, because we only had 10 of the first, 10 of the second, 10 of the third, and 10 of the fourth. And it's each individual group has to have a sample size over 30. Does that make sense? Had there been, let's say we asked 40 whites and 15 blacks, then you wouldn't have to make the assumption for whites, but you would have to make the assumption for blacks. Do you see that? So in this case, because again, I didn't want to sit there and type all day, you're going to have to assume for all of them because they're all under 30. But let me write that out. Since all, let's go, each of the sample sizes are not over 30. Any questions on that? Okay, so now the next one. Let's see if it'll let me do this. Yes. Okay. Do we need to assume that all the population standard deviations are equal?
Yes.
Yeah. Remember what I told you about finding out if they're equal?
You need to take a super advanced.
Exactly,
Yeah.
which means that for you guys, until you take another advanced class and learn how to do it and do it, you need to make the assumption. So the answer is we need to do that because we did not do an advanced statistical analysis on the standard deviations. Right. We did not, you'd have to do some advanced statistical analysis on the standard deviations to see if they're all the same or not. And we're not doing that. Okay. Any questions on that? Okay. Do we have to assume that we had no bias?
Yes.
Yeah, because if you look at this, it said a study was done. Did it say anything about how the study was done? No, had it said a study was done using simple random sampling to analyze the racial differences, then you wouldn't make that assumption. Do you see? You wouldn't need to say no bias because you know there's no bias. But it didn't say that. We don't know anything about how it was done. Any questions on that? Since there is no information about avoiding bias, whether they avoid WAG, whether they avoided bias. Any questions on that? Okay, let's look at number 4. The samples are independent. What do you think?
I think so.
Yeah, these are independent. This isn't asking one person 4 questions. This is asking a bunch of white people, a bunch of black people, a bunch of Hispanic people, and a bunch of others. So this one actually, you don't need to make the assumption on. Is not needed as an assumption, since this type of study is or let's go, uses independent sampling. Does that make sense? Okay, so we do not need to make the assumption that it's independent because with the study, it's clearly independent. Any questions on that? Okay, so now the samples are consistently taken. Do we need to assume the samples were consistently taken?
Yes.
Yeah, because this one we don't know, right? We don't know whether they, whether they approach white people the same way as they approach black people, the same way as they approach Hispanic, and the same way as they approach other races. Do you see that? Right? Hopefully they were done in the same way and they were consistently taken. But there's really no description. Since there's no discussion, on how the samples were taken. Does that make sense? Any questions at all on the assumptions? All right, so now let's show the details of an ANOVA test and let's state the inclusions in the context of the question. So start with H naught. It'll help to remind ourselves this. Am I going to write mu1 equals, should I just copy and paste this exactly? Should I just do this? What do you think? What's wrong with that?
Is the problem H naught?
Yeah, and H1 too, but let's start with H1. Okay, so the ... is not needed. How many different groups do we have?
I think 4.
4. You don't need ... with 4. what we can do, and again, we have white, black, Hispanic, other, and then fortunately they all start with different letters. That makes life a little easier for us. So I don't have to use the whole name, but I can go mu sub W instead of mu sub 1, because that shows it better. Equals mu sub B instead of mu sub 2 equals, not 3 dots, mu sub, we had H, I believe, yep. H equals, and then I think I can copy this as easiest. Mu sub O for other. Any questions on H naught? Okay, you don't need a dot, dot, dot when there's just 4 of them. If there are 50 of them, you dot, 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 but not with 4. Any questions on how H naught is done? Okay, so now we want to actually be more contextual in terms of H1, because it's a little too general for H1. So instead of just saying at least 2 of the population means different from each other, so these are mean what? These are mean distances from the library. So at least 2 of the races have a different population mean, different distance lived from the nearest library. Because that actually says what's going on. So you don't want to just, do some general nonsense, because it doesn't tell you anything. But at least 2 of the races have a different population mean distance lived from the nearest public library. Any questions on that? Okay. There's other ways of wording it, but you should word it so that it says this, basically. Okay, any questions at all so far? Okay, now I'm going to ask you, what's the name of the test that we're going to use? Question is, have you been paying attention? It's not a trick question.
The ANOVA test?
Yeah, so ANOVA. So the name of the test is ANOVA, short for analysis of variance, which really isn't about variance, because we're comparing means. Look at H naught. Okay, any questions on that? What do you think a good level of significance would be for this?
5%?
Yeah, this is sociology, right? How far you live from the library, that's very much sociology, right? So they always use 5%. Okay, so let's use 5%. Or 0.05. Any questions on that? Okay, what is the next thing do you think I need to do that you should be used to by now, since we've been doing this for a lot of weeks now?
To go to the calculator.
Yeah, so we need to go to the calculator. And here's the good news. Okay, how many more webinars do we have?
0.
Okay, so what calculator do you think it's going to be?
25.
Yep, it's the very last one. We're at the end. This truly is the very last statistics that we do in this whole course. Okay, and it's the ANOVA one. I tried to make it really easy. And if anything is confusing in the calculator, let me know and I'll make it less confusing. But you have to tell me, because to me, nothing's ever confusing, because I teach this stuff. But so far, no one's given me any suggestions this quarter. Like I said, so many that when I first made this calculator, you can thank those people for helping me make it a little easier to understand. Okay, so now it says enter the data value separated by commas. You're used to that. Okay. For example, 3, 4, 7, 9, -2, -8. Then hit calculate. So guess what? I just put them in. And I go over here. 15, 4, 11. Nine, 3, 2. And that's data 1. Okay, data 2. 12, 1, 6, 6. Any questions for data 2? Okay, and then I go to data 3, and that's 9, 17, 5. And then 14, 7, 1. And then I go to data 4, which is 18, 11, 2, 8. Any questions on entering the data? Okay, not too bad, right? I do want to let you know, if we want to do this, the difference in state weight example, could you use this calculator? No, this only goes up to 8. Is there a calculator that I've made that you can use? Yeah, the one that you use for a project has an ANOVA tab. And that, I think that, I'm pretty sure that's unlimited in the amount of things that you can put in. Okay, but most of you probably won't. I would never give you anything with more than 8 different categories because it's just too much typing. Do you agree? You wouldn't want to do it, right? Okay, but again, in the real world, you may have to. Sometimes there are more than 8 categories. Okay, it might be my months, for example. If you're doing something like, I don't know, how many vacation days do people take? Is there a difference by month? Well, then you'd have 12 different categories. And this wouldn't work. Okay, so I just want to give you a heads up. This will work for everything we do in this class, though. And for most people do, but not all. So that's just a big heads up. I didn't make the calculator work for everything in the world, just for everything in our class. Okay, except the projects, because I have to make you a spreadsheet or some universities don't accept it. So that was the reason. So you calculate. Okay, now here's something new. And that is letter F. We haven't seen that before. Okay, hopefully nothing about your grade. So F is the name of the distribution that happens with ANOVA. I will tell you that the mathematics of it is brutal. But the good news is you don't have to know any of that. Unless you want to become a mathematical statistics major. And then you need to learn all that stuff like I had to make this actually work. Because I had to code this stuff. Okay. And actually on this one, I think I used I used someone else's code for that. But for the spreadsheet one, I had to do it myself for different weird reasons. And boy, was it a lot of work. So I do want to let you know there's some very deep mathematics behind this that you are not responsible for. What you are responsible for is knowing this is called the test statistic. And that we've seen for over a month now. Okay. And you are responsible for knowing that this is called the p-value. So I use p for p-value. Okay, hopefully that was good enough for you. So the test statistic is about 3339, 0.3339. And it's F. And just note, we've had a lot of different distributions. So if you remember, we had like the binomial distribution, we had the uniform distribution, we had the normal distribution, we had the t-distribution, we had the chi-square distribution, and this is the last one. the F distribution. Okay. And the p-value is about 0.8. 0.80 is good enough, but 0.8 is good enough. Any questions on that? Okay, so you look at this, and what do you think we could conclude? And the point is, you don't have to have this weak stuff to know what to conclude after what I just found. At least the first few words.
We're going to fail to reject the null hypothesis and conclude that there is insufficient or statistically insufficient evidence.
It is statistically insignificant evidence to conclude that, and the good news is, I already have H1. I can copy and paste. I just have to make that at lowercase. That at least 2 of the races have a different population mean distance, live from the nearest public library, which hopefully you know is a fancy way of saying we don't know anything. Okay, and in this case, we really don't. How come? And not just because I said suppose and I made up the numbers, but let's pretend I didn't make up the numbers.
I think because we don't know which of the races are different from each other.
No.
No.
Look at our sample size, for example, with Black people. What is it?
Short?
Yeah, what is it exactly?
What do you mean?
What's the sample size?
Oh, 4.
4. Okay, and hopefully you're there. Should you ever do statistics with a sample size of 4 other than just for the class?
No.
The real world, never. Okay, so this would tell you nothing. Do you see that? So again, this is just an example for the class that I'm going to type in. But if I wanted to, really do a study, I'm going to have much larger samples. You should never trust anyone who does a sample size of 4 and says now they know about the country. That would be ridiculously terrible. Do you agree? So this is one of those cases where, yeah, you really don't know anything. Does that make sense? And by the way, even if we got a small p-value, you really still don't know anything. Do you know why? Because these assumptions are probably wrong. The nearest public library, how far you live, I doubt that's normal. It's possible, but I doubt that is normally distributed. I just don't think so. Okay. Are the standard deviations of how far people live from the nearest public library the same by race? No reason to think that's true, right? Do you see that? So this is just good for the class. It's not good for reality. There's a lot more to doing ANOVA than what we're doing in this class. So I want to really give you the heads up. Don't think you fully understand ANOVA in today, because these assumptions, they're really hard to show for most of the assumptions. Any questions on that? Okay, so that's a big heads up in terms of ANOVA. But for a class, we'll do it. We'll pretend. In the real world, you have to have a lot more, much bigger sample sizes. You have to really check the assumptions in a sophisticated way. You got to do it right. Okay. And if you don't want to take another stats class and you need to do it, you better read a stats book, an advanced stats book, instead of taking the class. The point is, you need to learn about this stuff, And a book could be online, by the way, that's fine. Sure, Wikipedia's got plenty on it. Okay. And one of the things, by the way, Wikipedia is pretty good. See, Wikipedia is not trustworthy for a lot of things. It's very trustworthy for math because there's very little, there's no debate about math. you know, it works. You know, it's proven, it's done. Do you know what I mean? Whereas for some things where it's, you know, if you're looking at something that is, you know, Republican Party oriented or Democrat Party orientedly, Wikipedia is probably not a good source because it's just people putting what they feel. But with math things, actually, it's pretty good. I don't think I've ever seen anything wrong. You know, so that's a good thing. I want to mention another big thing is that let's say you found that there was statistically significant evidence. Let's say we did another study with a large sample size and, you know, where we were able to make the assumptions all work without having to like really make them assumptions, you know, just because we did it right. And we found, let's say we got a p-value of 0.02. Okay, what would, first thing, what would the only difference be in the conclusion? Very small difference in terms of the wording or the lettering.
You would change insignificant to significant.
Yeah. So all of a sudden you would have their statistically significant evidence to conclude. Do you see that? So again, I don't think I need to do like a whole bunch of examples, but I need to explain what would happen had the p-value been small. Is that n would have gone away. Is that clear? Okay, now I want to give you another heads up about the fact what you're not learning in this class. So had we found significant evidence, does that tell us which two races are different from each other? Right? Which one's off? You know what I mean? It doesn't. ANOVA doesn't tell you which ones are different. Do you see? Even if you have a very small p-value, it tells you there's differences, but it doesn't tell you which are different. Do you see that? So does that mean you can't figure out or find out which are different? Any guess on what you'd have to do to find out?
Take a more intense math class.
Yeah, statistics. Yeah, you take an advanced statistics class and you learn about Tukey analysis. You probably never heard of it before, but you can just trust me. There's something called Tukey analysis that does this. And there are ways of doing these things. So just because we haven't talked about it doesn't mean it can't be done. It just means that it's more advanced than this class does. Okay, but what it does mean is that if all you know is this class, don't even pretend to know which ones are different. Do you see? If you really want to find out, you just got to do more stats. Okay, or if it's your business, hire someone who knows. But that's expensive, by the way. Okay, does that make sense? Okay, so ANOVA really only tells you, is there a difference? It doesn't tell you what difference. Any questions on that? Any other questions about ANOVA? Okay, so this is actually the very last statistics we've got in this whole course, in all of elementary statistics. So what should I do next? You should know by now. No one's telling me? I should give you a secret word. Hopefully you know that. So here's a secret word since it's the very end. And it's thank you. And I want to thank you for being polite. And for at least those of you who are coming and watching, thank you for everything. And make sure you spell thank you right when you put in the secret word quiz. But that's a secret word for the final webinar of the course. There is not a webinar next week, by the way. Because I figure if I gave a webinar, let's say Monday night, well, if you took the final on Monday in the daytime, what's the point? You're done. Do you see? So I don't do a webinar during finals week because for some of you, you're really done. There's nothing more to put in a webinar. So this really is the very last webinar of the quarter. It does not mean I'm not here for you. So I'm still be watching I'll still be watching the discussion boards, and I'll be checking my email as long as I have internet. It's snowing still pretty hard right now outside. And so I'll be able to check, and I'll also be able to help you, when you get into your upper division coursework or graduate coursework. I'm happy to help you then too. Just send me an email. But, if you have a small sample size, I'm going to be honest and let you know that no, your dissertation is not going to work, at least not statistically, and not, if you want to get published, it's not going to happen, not if the reviewers are doing the right thing. So make sure your sample sizes are big. Okay, there's all kinds of things that you have to make sure of. But I have helped many, many students. And I want to ask you, if you get a PhD, send me your dissertation. I love reading people's dissertations. But don't expect me to understand everything if it's a dissertation that's not in math. But I'll still read it. It's always fun. And I do that. I read past it. I've had a lot of students make it, which is kind of cool, that far. That's as far as you can get, by the way, in terms of education, at least. And then if you have a business and you need help, then, as I mentioned, I think I mentioned this one before, I will help you, but there's a charge. But who do you pay? Not me. You pay our foundation office to give a scholarship. So I'll do the work, but I'll expect you to donate to a scholarship. The amount that I would have charged had I been, some private person. So that's my ask of you, is that if it's for a business and you're making money off of it, then I want you to donate to a scholarship. And the good news is that way I feel like I've donated a scholarship, but I don't have to pay taxes on the money you would have given me. And that's legal, by the way. I'm not like, cheating the government or anything. I'm allowed to do that. So that's just a note in terms of, in the future. If it's far in the future, you have to hope I'm alive still, But that's just a note. So I want to remind you, let's go here. First thing, March 26th is when your project is due. And today's March 21st. That's not a long time from now, by the way. And then Thursday morning again is when you have to have your draft to me by, if you want me to look at it. Braulio will also take a look and answer questions and help you. So we're both around. So there's definitely a lot of help. Don't expect to, if you send me anything at night, you're not going to get anything back until morning at least, because I'm sleeping. Just a note, I sleep early. And but I'm happy to help you out. And I want to mention the final, which is only 10% of the grade. It's not a huge part of the grade, much less than like a regular final exam. But the final covers everything. Okay, there's a little bit more weight for ANOVA because you haven't been tested on that yet. So there's more weight on ANOVA. As you might guess, any of the type out your answer questions that I have to grade, those will be ANOVA. So expect it. Okay, so hopefully that makes sense. I want to mention another thing, and some of you already know, but if you don't get a 10 out of 10 on your discussion board post for this week, you're just not on top of it. There's nothing hard on this one. There's no statistics to do. Let's just put it this way. So it just means that you're just a procrastinator, you did it late, or you didn't even bother. So this should be this is the easiest discussion assignment there is. I think it's even easier than the one where you had to do the 2 truths and 1 untruth. And that was also one you should get a 10 out of 10 on, right? Make sure you read the instructions, so you do what it says. But it's an easy one. So don't just not do it. That would be stupid. Let's put it this way. So make sure you do your discussion post, and you do it today, whenever. You don't need to read any stats to do it. Just let you know that. So, just get it done. Okay, so that should be a super easy one. Hopefully that makes sense. And even ANOVA's, this is an easy week when it comes to new stuff. Really, the only hard thing is your project. And the final exam has the same rules and type as your other exams, in that it covers everything we've already covered. By the way, everything we've already covered is everything, because there's nothing left to cover. So that's why I call it a final exam, even though I could have called it a week 12 exam. It's due on Wednesday, don't forget, not on Sunday. Okay, because the course is gone and over and the campus is closed by then and all that. So just a note. So it's due on Wednesday. And but it does cover everything in the course. A little more weight on ANOVA, but it does cover everything. So, you know, you can always redo the basically it's the same as the rest. So let's see. When will the test be graded? Today, hopefully. If you haven't already seen your grade, then you'll see it. It takes me a long time to grade these, by the way. I type a lot. It takes me many hours. So I'm about 2/3 of the way done with all of them. And so I have 1/3 left, and I started today. But I did a lot of hours. I subbed for my office mate who was out, and to give a test, which means I could sit there and just grade your stuff all for 2 hours, and still didn't even get halfway done. So it does take hours for me to do it. So hopefully today, if not today, definitely by tomorrow morning, but probably by today. A lot has to do with how many people come to my office hours, because I'll do it during office hours too. Okay. Hopefully that answers your question. So just to note that that's really all that's left in this class. You know, class is mostly done. And the final grade, you won't see on your transcript until the college puts it there. And it usually takes them like over a week to do that. So just let you know that, is that I have no control over that. So if you need to like send your transcript off to a university or something to show that you passed, you're gonna have to be a little patient, because the college waits a week. So that's just a note in terms of when you'll see your final grade. The project grade, you know, that takes me time. So we'll see how long I can, you know, you send it in Sunday, and then I'll be working on it Monday and Tuesday and Wednesday, you know, that kind of thing. And then your exam, your final exam might take me a little longer, because I'm in hiring interview meetings Thursday, Friday, all day. So it might take me longer than normal, because I'm going to be interviewing people for a job. And that's something we faculty do, is that there's a large group of us that interview. And as far as I know, none of you are applying for the job. So okay. Any questions? About the project, by the way? Just a few things to note. I want to just keep saying this over and over again. For everything you write, you do, for every statistics, a p-value, the level of significance, the lower bound of the confidence interval, the upper bound separately, by the way, not together. Talk about what decisions will your client make after seeing it. That's probably most of your project, is writing about that. Don't just write the definition of a p-value. You know, make sure you talk about, after seeing that p-value, now what is the client, what's the client going to do? How's the client going to react? What decisions will the client make? Does that make sense? After looking at the upper bound for the confidence interval, well, how might the client react or act? After looking at the lower bound, how might the client act or react? Those are different, because your lower bound and upper bound aren't the same numbers. Okay, so make sure you write about all of those things, you know, for everything you do. Most of the project should be about the hypothesis test and the confidence interval. The other should be a small part of your project. So things like the individual statistics, very small part. Okay, the sampling technique, one sentence is all you really need. You don't have to get into deep depth of that. It's this project's focus is the hypothesis test and the confidence interval. So make sure you're focusing on that. And hopefully I was clear before, but I want to doubly let you know. Okay. Are there any questions? And if not, what I'll do is I'll stop the recording. And then if you have questions that you don't want to share with everyone in the world, we'll do that. So I'm going to stop the recording. But with Zoom, it always takes a moment or two.